All right, this segment we're going to talk about electronics. And I've said before, nitrous is definitely the best bang for the buck and the least expensive power adder you can possibly put on your car. But it's also the simplest system. But there are times when you're going to want electronics. And especially like with a dual stage system or a three-stage system, you're going to need electronics. Delay boxes to activate the second stage of nitrous and to bring the first stage in, then delay it to the second stage, little things like that. Well, there's also other electronics that you can do too, especially for race applications. Street applications, you really don't need this kind of stuff. But when you get into the race stuff and you're really trying to squeeze out everything you can and get every advantage you can, electronics help. And these are some simple ones right here. There's all kinds of brands that make them, but these are the simplest ones right here. This is from NOS. This is basically just a simple on-off switch. And what this does is you wire it in. All these come with great instructions, so they're really simple. You're not talking about having to be a wiring engineer and wizard to do all this kind of stuff. So it is simple. What this basically does is it turns your nitrous system on and off. It can also be to turn on your second system or your first system, depending on if you have a single stage or a dual stage system. But basically what this does is you have two chips down in here. You can see there's a 3000 chip and a 6000 chip. What this does when it's wired in, it'll turn the solenoids on at 3000 RPM and it'll turn them back off at 6000 RPM. So it kind of acts like a safety feature. So you can be on the throttle. This really comes in handy when you have throttle activated solenoids rather than on the button, because like I said before, it's hard to control your foot to know where you're at, or if the system's armed, you don't know when it's going to come in unless you're really hard on the floor. And you don't want it to come in first gear or partway through second. You want it to come most of the way through second and third and fourth. So what this does, you don't have to worry about that. You don't have to worry about when you're pushing the button or how far your throttle pedal is pushed. What this does is these are all adjustable. You can put whatever chip you want in here. You could have it come in at 2000 RPM and go out at 4000 if you want, or you could have it come in at 4000 RPM and go out at 8. It's a simple, just depending on what you want and what you're looking for. So something like this is really inexpensive. It's a good safety feature to have, and it takes more work out of what you're trying to concentrate on. It lets you more concentrate on going down the track. Now another type of electronic system right here, this is from Jacobs Electronics. They make some really fine stuff too. This is just an all-around nitrous controller. And basically what this does, it's got several different controls on it. This controls when the nitrous comes in, how much it's going to retard your timing. And we'll get into that when we get into ignition systems and stuff, because you definitely want to retard the timing on, especially on big shots of nitrous. Smaller shots, you don't have to worry about that. But when you're talking where these electronics are put onto, that's race stuff. You're going to have this in a race car. So you're definitely going to want to have the timing retarded, okay, when you're on bigger shots of nitrous. So what this does is it tells you anywhere from nothing to 15 degrees as to when the nitrous comes in, how much it's going to retard the timing back. Okay, the next little guy on here is the first stage on. This, by RPM, there's 1000, and over here there's all the way up to a 6 as to when you want the first stage of nitrous to come on. So that's your initial shot, say 100 horsepower. If you have a two-stage system and the second amount of power that comes in is a 200 horse shot, that's what this one adjusts. So you can have your 100 horse shot come in at this RPM and your second stage of like maybe a 200 horsepower shot come in at whatever RPM you want to set right here. Then the last little guy here is just a rev limit. It just acts as a rev limiter. In case you don't have one built in, this has a rev limiter built in. Slick little setups. Actually, it looks like there's a lot of wires here and stuff, but the schematics and the directions are really simple. They're laid out really nice, and really in a very short amount of time, you can have a controller like this mounted in your car, and it just takes the effort off of you and lets you drive the car. Because trust me, when you got a dual stage system kicking in, you got 400 extra horsepower, 500, even 600 horsepower, that car is up, down, left, and right, and all over the place. You got other things to be thinking about than when the button's pushed or where it's going to go. Your car's going to be going any which way you're going to be pointing it. So all you got to do is hang on. Let the control boxes and everything take care of everything else for you. All right, this segment right here is on ignition systems. Now, we've already talked about spark plugs before when we talked about jetting, so we learned how to read a spark plug. We're going to reiterate on some of that stuff through this segment here. And I did say in spark plugs, don't fall for the gimmicks, the split-tip spark plugs or all that fancy, expensive stuff that you didn't need it. Ignition systems are a little different, and even though the spark plug's part of the ignition system, I showed them to you earlier in the jetting because you need to read the spark plugs to see what the jetting is. Well, the ignition system is very important also. And reason being is you're adding nitrous oxide. We've said this before. Nitrous is very simple. It's just an oxidizer. Well, you're meeting the fuel. The object of the nitrous is to burn more fuel. Well, the more fuel in the cylinder, the harder it is to light. I mean, that's a very wet, dense mixture inside the cylinder. It's hard to light. Imagine trying to light a match in the rain or something like that. It's too much moisture in the air, okay? Same thing, even fuel. Fuel can only burn in a given air-fuel ratio, an optimum air-fuel ratio. It can burn on the upside of that and downside of that, but you really want like between a 12-to-1 and a 14-to-1 air-fuel ratio for any type of different given vehicles. 12-to-1 being on the rich side, 14-to-1 being on a lean side. Of course, you wouldn't want to run a nitrous engine on 14-to-1 side. You'd be wanting more on the 13, 12.5, or 12-to-1 side because you want it on the rich, and that's the air-fuel ratio. But ignition systems, you obviously need to have a little bit more juice behind it, a little more amperage, a little more voltage to get a more intense spark to light that wet mixture. And we do that with different systems. You want to upgrade it. A real good one to get is MSD. This is a 6AL box. What this does, MSD is multiple spark discharge. Basically what that does, instead of a spark plug going off once, it goes off in several times. It goes snap, 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 snap in a nanosecond. I mean, just a few snaps. That just gives a longer spark duration time because inside this combustion chamber, you've got a high swirl rate inside there. I mean, it's like a vortex of wet fuel and air flying around inside there. So sometimes the first spark can't really ignite it very well. So what this does, it helps it ignite. Now, I've got lots of other DVDs out on heads porting and valve trains and superchargers and all kinds of stuff. And in a lot of those, I say elaborate ignition systems aren't needed. Yeah, and we also reiterate on that, not needed for basic stock systems, basic stock engines. When you get into this kind of stuff, supercharging or nitrous or turbos, you do need this kind of stuff. But if you go and spend $400 or $500 on an ignition system and you got a stock vehicle, you're not going to see a single horsepower gain. It's not going to do anything. Why? Simple. You didn't need it. The car is already burning efficiently, so you can't burn it any better. Okay, if it takes a match to light a fire in a fire pit and you light it with a blowtorch, it doesn't matter. The fire pit's, because of the fuel and the amount of oxygen in there, it's only going to burn at a given rate no matter what you light it with. Same thing, but if you can't light it, you're trying to light a match and it's raining outside, it's obviously better to light it with a blowtorch in the rain than it is with a match because a match ain't going to light it. Same thing inside the combustion chamber. Your very wet, dense mixture, you need more amperage and voltage to really fire that cylinder off. If you're not dropping cylinders, if you're not going down the track or down the freeway or whatever and under full throttle conditions and going, if you're not missing like that, you don't need to upgrade your ignition system. But anytime you're going to increase power with nitrous oxide, anything above 50 horsepower, 60 horsepower shot, it's a good idea to buy a system like this. What this does, it intensifies the spark, it increases the spark duration time, and it's just all around good. Plus the 6AL, the L stands for rev limiter. It has a built-in rev limiter. You can change chips and it just saves the motor. Because I talked about that before. When you're on nitrous, the motor's going to tack up faster. As soon as you hit the nitrous button, if you're at 5,000 RPM, it's going to go 5 to 7, just like that. I mean, it's going to scream. Where if you weren't on it, the tack will slowly climb up. Hit the nitrous, goes up, and the tachometer will kick right on over. Well, what this does, it just saves the motor. It's good to have a rev limit. So we get into distributors also. It's a good idea to have a good, solid foundation for a distributor. This is a billet aluminum one, also from MSD. Several other companies make good distributors. We use a lot of MSD products here. They're full bearinged inside. They're billet. They're very stable, magnetic pickups. You're not going to find a better distributor that you could run for a nitrous system. Again, if it's a stock motor, it's pretty overkill. But if you're adding pretty good juices or amounts of juice to your system, and you're 100 horsepower or above or 150 and start getting up into that range, you're going to want to upgrade this kind of stuff and get a more stable ignition system to get a good fire. And that includes things like spark plug wires. You want to be sure you got a good set of wires. You get a couple of misfires in an engine that's running nitrous, and that could be a catastrophe. So you want to be sure all the ignition system's working perfectly. Now, another thing we're going to talk about too in ignition is anytime you're on the juice and you got the button pushed or you're on the throttle and you got nitrous flowing, you're going to want to retard the timing. And just a rule of thumb, you're at 100 or 125 horsepower shot, you're going to want to retard the timing back about 4 degrees. It's equal to about 1 to 1.5 degrees of timing you want to pull back for every 50 horsepower. So if you had 100 horsepower and you're at 1 to 1.5 and 1.5 is 3. So you're right in that area right there. So somewhere up around the 4 degree retard is where you're going to want to be. Well, it's kind of a bummer because if you don't have an electronic control for your car, that means you're driving around without the nitrous on and your timing's retarded. It's kind of a bloomin' turd. And it can run warm. Anytime the timing's retarded, your ignition, your throttle response is going to get sluggish. The idle vacuum is going to drop a little bit. It's just not going to have the pickup it had. Anytime you over-advance the timing, though, or not over-advance, but you advance it to its fullest potential, your idle vacuum will go up, your throttle response will go up, everything's up. But man, you hit the nitrous when you're fully advanced, and you're asking for detonation problems. So for every give, there's a take. So you got to kind of split the difference there. You got to tell yourself, well, I'm going to be on the nitrous a lot today. Well, then you might want to bring the timing back. Or, gee, I'm not going to use the nitrous this week, or my bottle's empty. Well, then put a little note on your dash, timing's advanced or whatever. And that's okay. You can do that and advance your timing to where it should be normally. Well, a remedy for that, for not having to remember all that stuff, we showed this earlier too, is a Jacobs unit. MSD makes units like this also. So when the nitrous is engaged and you've got the system working, this little adjuster right here is a timing retard. So when the nitrous system is on, you can adjust the retard of the timing. So what this does is when you're normally driving around, you can be at, say, 34 degrees total advance or 36 degrees total advance. When you arm the system and hit the nitrous, it could jump on back anywhere from nothing to 15 degrees of retard. So you can set it for, say, 6 degrees or something like that. So when you arm your nitrous system, bam, it kicks the timing back 6 degrees, engine's safe, no detonation problems. That's a really good feature to have. MSD makes them too, where they're not in a whole box like this. They're just a single little box, a control box that can plug in line with a 6AL, so when the nitrous is on, it tells the timing, kick back. Simple little system, and it saves your motor. It's worth the little bit of money you spend on something like this to save your motor, because then you can have a lot more fun with it for a lot longer and remove the risk of damaging anything. Because let's say you do advance the timing and you forget about it, and then you go hitting the nitrous later on. You went and refilled your bottle and hit the nitrous. You're going to detonate. You're going to blow a piston or blow a head gasket and stuff, and it was just, oh man, you're talking about a few hundred to maybe a few $1,000s to fix that. A couple $100, you could have had it taken care of in the beginning, and it always fixes itself. So whenever you arm that system, it automatically takes care of the timing. That's a good way to go. Now, another thing some people ask is, hey Aaron, you know, if I put nitrous in my late model car, do I need to get a chip for it or anything like that? Should I have a new chip burned? Not really. Or if you have an existing chip, okay, that's another question I get. You know, hey Aaron, I got a chip in my car. Will that work with nitrous? Probably not. Because the chips that they put in the ECUs to increase your power change the timing curve, change the fuel curve, and stuff like that. But the main thing is they change the timing curve. Well, the timing's totally different for naturally aspirated to something like nitrous or turbos or superchargers, anything like that. So again, we already said, when you activate the nitrous, you want to pull the timing back. Well, chances are the chip that you have in your ECU to upgrade for performance advance the timing so you get a little more out of it and everything. Well, that's not good. You're going to talk about getting detonation problems. So if you're going to order a chip, say you got a late model car and you want to order a chip for it for your ECU, to have the engine run better, make sure they know you either have or you're planning on running nitrous, and they will adjust that in there so it will work properly with it and adjust the timing accordingly. Otherwise, you know, your chances are you're going to hurt the motor. All right, you know, one of the first mistakes people make with ignition systems when they get an elaborate ignition system on, or a big coil or something like that, is they start opening up the plug gaps. And you don't want to do that. Anytime you increase power, like to give you an idea, most performance motors, we start decreasing the plug gap. That includes nitrous motors, supercharged motors, even naturally aspirated high horsepower motors. A good rule of thumb is always start at 35 thousandths and work your way back a little bit from that. But like I say, the first mistake people make is they go, oh, I got a high energy ignition on here. I'm going to open my plug gap up to 45 or 55 thousandths or something. That's not real good. That makes a big weak spark. You want a small intense spark. And you start closing the gaps up. Otherwise, you can start getting misfires. And a good way to tell this is just start at 35 thousandths, take your car out, run it a little bit, come back, see how it ran, say, okay, well, that ran pretty good. If you want to increase it to 37 or 38 thousandths. Go out and run it again, see how it runs. Come back, find out. Then go back down, go down to 32 thousandths or 30 thousandths and see how it ran. And just kind of take a mental note on, wow, it ran really good here. On the high end, it sputtered when I opened the gap up, but it didn't when I went smaller. Well, then go smaller. Anytime you run nitrous or anything like that, you're going to want to decrease it down to 25 or 30 thousandths, usually right around 30, 32. If you're running big shot of nitrous, 200, 250 horse, something like that, you're going to get down to around 25 thousandths or so, or maybe a little bit bigger shot like that, 300 horse, you're going to be down in the 25 thousandths area. So, you know, you do decrease the plug gap on size, not increase it. So you definitely don't want to do that. Anytime you're having spark plug problems or ignition problems, first thing you're going to want to do is decrease the nitrous jet size at the solenoid first. You can increase the fuel side, but better to lay back the nitrous than to do anything else. So start decreasing the nitrous and see if it goes away. Remember we talked about earlier, the number one thing you can do bad to a nitrous motor is lean it out. Don't lean it out. Well, anytime you add more nitrous, you're leaning it out. You're adding oxygen to it. That leans the mixture out. Don't do that. So if you're having spark plug troubles where it's like running rich, or like here's a spark plug right here. If you see the ground strap, up here is turning blue, something like that, that's telling you it's getting too hot in there, or it's starting to melt a little bit. Start decreasing the nitrous amount, okay? If that doesn't go away, you can switch to a colder spark plug, but it's telling you that you're probably too lean and you want to start backing the nitrous back off and readjust the air-fuel, or the nitrous-fuel ratio by decreasing the nitrous a little bit. Also, when you're checking spark plugs, check every spark plug. Don't just check one. Don't check the easiest one, like on number 1 cylinder, and go, oh, I checked that one right there. Especially with open plenum manifolds, you got an open plenum there, and you got a spray bar of nitrous, and it's spraying, and you got swirls going in there, and you got long runners and short runners, and all kinds of things that can factor and take effect as to which cylinder runs a little leaner and which one runs a little richer. And you want to check them all, because you might have picked one that is on a rich side, or let's say number 1 cylinder there has a slightly bad ring or a slightly bad valve guide or a valve seal, and it's making the plug look a little dark, and it's actually oil deposits. Well, if you're looking at it, you go, no, I'm rich, the plug's black, and you start increasing the nitrous amount. Well, it really wasn't black so much from gas or for fuel, it was from a little bit of oil. Now you start increasing and you didn't check the other plugs, and they're on the lean side, you're going to smoke the motor. Wasn't worth it for another 10 minutes worth of work to pull all the plugs out and look at them just to be sure. If you're a novice and you're just starting on this stuff, it's going to take you a while to learn how to read the plugs. That's why I showed you very highly detailed of what each plug looks like. But you're going to have to take some time to learn that and get used to that and what they look like, and be able to look at it and go, yep, that one right there has a little blue strap, or this one's got silver and black deposits on it. You start looking at the electrode down inside here, there's the porcelain inside. That porcelain can tell the whole story. If you got little black or silver specks on that right there, that's telling you got detonation problems. And you see little teeny specks. That's little pieces of piston and metal and all kinds of stuff in there and different types of carbon that happen and stuff like that start building up on that. Well, that's telling you, hey, start laying back the nitrous. Don't increase the nitrous. Start laying it back, or go to a colder spark plug. But first thing you should always do, even before you mess with the spark plug, spark plugs cost you money. To change a jet, your kit came with jets, so go down a size on the nitrous jet and decrease that, and that'll help you do that. Well, while we're on the subject of jetting and getting the correct air-fuel ratio so you don't harm your motor, I want to show you a neat little thing here from Innovative Motorsports. This is basically an air-fuel ratio reader, and what it does is it tells you your air-fuel ratio in real time, whether it's 12 to 1, 13.2 to 1, or 14.6 to 1, doesn't matter, anything in between there, it'll tell you. So you'll know whether you're lean or rich as you're going down the road or down the track. It's a neat little setup. It tells you in real time the actual air-fuel ratio that you have, and it stores settings. So if you're racing down the track, you don't have to keep your eyes on it. You can keep your eyes on the track and keep your car pointed in a safe direction. Then once you get back in the pits, you can recall at different shift points or anything and look at it and say, wow, I was lean here or I was rich there. And that'll help you better tune your engine. These things really hook up easily. They're really nice because you have a power supply here that just plugs into a cigarette lighter, so it doesn't have to be a permanent installation. And of course, you will have to put an O2 sensor in the exhaust. I mean, that's how these things read, is with the exhaust gas coming out. If it's lean, it's going to have oxygen content, and this will tell it what it is. If it has less oxygen content, then it's going to tell you you're on the rich side. So it just gives you a reading on that. Now, Edelbrock makes one also. It's a little less expensive, a little simpler design. It's got LEDs, and it also reads in real time, but it doesn't store anything. So you can mount it under your dash, and you got to kind of watch it in real time as you're driving. It doesn't quite have the features of this, but it's also a great little bargain price for something like that, and it'll really help you tune. And keep in mind, we talked about if you run too lean, you can really damage your engine. If you run too rich too, you can get cylinder washed down and problems like that too, so you don't want to be too rich either. But one of these will really help you get the tuning job done, and you'll be running as best as you can. Well, in this segment, we're going to talk about internal engine components and the different types of components you need to really make an engine strong enough to withstand a big shot of nitrous. Of course, we already said earlier, if you have a stock engine and you're running a moderate amount of nitrous that's within reason of what the engine can handle, you don't need to do any of this. But if you're going to hit the racetrack, or you're going to go out and blow your buddy's doors off or something like that, and you're really going to hit some good juice to it, you're going to need to upgrade some parts, and that's what we're going to talk about in here. Let's start with the blocks first. Right here we got two different engine blocks. This one right here is just your typical small block Chevy, just nothing fancy. This is a 4-bolt main block, and we're going to explain what that is, because I know some of you out there don't know what a 2-bolt main block is or a 4-bolt main, so I'm going to show you right here. It's real simple. This is where the crankshaft rides in the holes right here. The crankshaft runs long ways inside the block. These are the main caps that run all the way along here. Okay, it's real simple. 4-bolt main blocks have 4 bolts holding the main caps on. 1, 2, 3, 4. Real simple. Okay. Obviously on Chevrolets and some factory blocks, they do have a 2-bolt cap on the very end, on the front side up here, and on the very back cap back here is also a 2-bolt cap. But the center caps are 4 bolts. Now obviously you can buy a race block or an aftermarket block like a Dart or a Ford Motorsport or a World Products or any of the good blocks, Donovan. I mean, there's all kinds of good aftermarket blocks. And those obviously are going to have the 4-bolt caps and everything's going to be super duty, super strong. I'm just talking about stock blocks right here, something that's reasonably priced that the majority of you would probably be using out there. So a 4-bolt main, that's basically all it is. Just means there's 4 bolts holding the main caps in. And what holds the crankshaft in? The main caps. So, you know, there's just twice the clamping power or twice the clamping force is holding the main caps in. Let's look at a Ford right here. This right here is a 460 based engine. It's a 545 cubic inch stroker that we're building for a customer of ours. This one is a Ford block. Factory Ford blocks are 2-bolt mains. Almost all of them are. The only ones that came 4-bolt mains from the factory were the Boss blocks, Boss 302s, Boss 429s, Boss 351 Clevelands, stuff like that. Those are pretty far and few between. It's like trying to find a chicken with lips. They just almost don't exist, okay? Especially in the normal performance world out there, you're just not going to find them every day. So we're talking about your typical standard blocks, everything from a 289 to a 302 to a 351 Windsor, a standard 351 Cleveland, all your 429, 460 blocks, all that stuff, they're all 2-bolt mains, okay? So you might think, well, geez, a 2-bolt main's not as strong as a 4-bolt, and a lot of people think that, and that's wrong. There's other factors that become involved with that. One thing is, let's look at this. Look at the size of this main cap right here. This is a monster. Another thing is, these are studs, and the stud size on here are 1/2 inch. The stud size on that small block Chevy right there, 7/16. They're a lot smaller. You got one that's the size of my my finger here, and you got one that's the size of my little finger. Okay, so I mean the Chevys have a little bolt, and the Fords have a big one. So maybe it's only 2-bolt main, but the studs or the bolts holding it in are a lot bigger, and the main caps are a lot bigger and stronger. So there's always a give for a take. It just depends on what you're looking at. So you always have to compare apples to apples and oranges to oranges. So a lot of people say, oh, Chevys are a lot stronger because they have the 4 bolts and Fords don't. That's not true. So we're looking at something like this. I mean, this thing right here, like I say, it's 545 cubic inches. It's got a billet steel crankshaft in it. It's got 6.7 inch long H-beam rods, 4340 steel H-beam rods, JE pistons. I mean, it's got the whole works, the solid roller camshaft. It's an animal. But you might be noticing something on here that a lot of times you don't notice. This has a billet main support. These things right here are designed for the Ford motors. They make them for other motors also, but Fords mainly, because what it does is it ties all the main caps together. So yes, it's a 2-bolt block, but yes, it's stronger because the main caps are bigger and the studs are larger. But this girdle right here, some people call it a girdle, but it's really a main support. It ties all these together. So really what kills an engine is main cap walk and block deflection. And that just means the block flexing as it's making all the power. You're on wide open throttle and you got the nitrous on, or you got a supercharger or something like that, and it blocks, you get deflection, it's moving. Or main cap walk, and that's when these main caps on here start wiggling back and forth. Well, there goes your main bearings, okay? Just because of wiggle. Well, what happens is this main support ties them all together. So if this one right here wants to try and wiggle, it's got to try and wiggle all these others also. Not going to happen because the load is changing throughout the crankshaft. As every fire, the load's changing on the crankshaft constantly. So it disperses the load evenly. They don't make them for Chevys. Okay, so you're looking at a Chevy here, 4-bolt main, but that's what you get. There's no main supports available for these. They just don't fit very well. So again, every give there's a take. So you can make a 2-bolt main stronger by adding a main support or adding studs and stuff like that. If it's a small shot of nitrous, a 2-bolt main, that's fine. Let me give you an example. You've probably, Corvettes, early Corvettes, early Shelbys and things like that. All the muscle cars from the really early era, when muscle cars really first started coming up. Take a 63 Corvette, 365 horsepower, 327, all right? They're good for 7,000, 8,000 RPM. Guys used to overwind those all the time. You ever see a crank come flying out of one of those? No, they're 2-bolt main. How about the 68 Z28s? They had little 302 cubic inch Chevys in those things. They're screaming little motor, notorious 8,000 RPM motors. You ever see a crankshaft come flying out of a Z28? No. 2-bolt main blocks. They didn't make a 4-bolt main one. The 69 did, later 69 ones, but the 68 one, they're all 2-bolt main. You look at early Shelbys, 65, 66 Shelbys, things like that. The 289 K-code motors, 2-bolt main. You ever see a crankshaft come flying out of a Shelby? No. So there's a real misconception about 4-bolt mains. You got to have it. I haven't seen too many crankshafts come flying out of 2-bolt main motor, so you know, the validity of whether you really need it is really not there. But on the flip side of that, anytime you increase cylinder pressure, be it by increasing compression, by adding a supercharger, or adding nitrous oxide, you're pushing down on that crank. You got a piston and a rod, and it's forcing that crank around. So your downforce on the crankshaft and the crank trying to go out the bottom of the motor obviously is increased. So obviously if you have a stronger setup holding the crankshaft in, yeah, it's stronger. But it's not like there's an inherent problem with a 2-bolt main anyway. Like I say, how many crankshafts you ever seen come flying out? So there's kind of a misconception about needing a 4-bolt main or not needing it. But obviously, you know, these days we're getting 400, 500, 600 horsepower out of some of these small block motors, and way beyond that. This is a 700 horsepower motor. So, you know, on motors like this, that's going way beyond what the people that designed the block ever thought these motors would ever have. So sure, we need to strengthen them up. So anytime you're going to add a shot of nitrous that's like, say, 200 horsepower or above, or maybe even 150 and above, but somewhere's right in there and up, you're going to want to strengthen things, have a 4-bolt main or a 2-bolt with a main support, and add the components that we're going to be talking about next. Well, we're looking at all the components right here inside the motor. All right, let's start off with the crankshaft. First and foremost, do you need a forged crankshaft for a moderate amount of nitrous? No, a cast iron crank will take a lot more abuse than you think it will. If you're building a motor from scratch, though, for racing purposes, I mean, it's a no-brainer to buy a good forged crank. This one right here from Scat, it's a good inexpensive crank. Eagle makes also good inexpensive cranks. They're 4340 steel, good bang for the buck. Of course, you can get into better cranks. You can get up into Lunati crankshafts or Crowler cranks and things like that. You start paying a little more, but the strength and the quality goes up. Much like buying tools. You can buy some real high-end tools, and they're quite expensive. Or you can buy some middle-of-the-road tools, and they're pretty good, and you can use them real good, like a Craftsman tool, something like that. Great bang for the buck. But you get the Taiwan stuff or the Chinese tools, they break the first time you use them. You know, the socket set was $3.99 for a reason. You don't want to have those kind of tools because they're junk. I mean, you can't even use them for fishing weights. All right, that's about the only thing they're good for. So same thing with internal engine components. You know, horsepower has nothing to do with how much an engine costs or anything like that. It's all the components to build the motors where the money goes into. You want to be sure you get good enough quality. But something like a Scat crank, this is a 4340 steel crank. If you're going to have horsepower of 500 horsepower or above, you might want to go to a forged crank, or that's when you really start needing one. Anything below 450, 475 on back, shoot, a stock crank, I've seen stock cranks take a lot more abuse than that. So a regular cast iron crank would be fine. So crankshafts, if you're going to be going, you know, high on the horsepower, go ahead and get a forged, something like that. We'll look at the rods. There's a misconception. A lot of people say, oh, I got forged rods or forged alloy rods. Let me say this. About 98 to 99% of all rods out there are forged right from the factory. There are very few cast rods out there. Cast iron is very brittle. It just isn't very strong. And it has a very weak shear strength, so it doesn't like any side-to-side motion at all. You know, it would rather not stretch or bend or move. It'd rather just snap. It's brittle. Some engines had those. Some of the early Pontiacs or Oldsmobiles and things like that, they had cast rods. And this is one right here. If you look at it, it's very stipply looking. And these are kind of rare. You don't see these very often. Of course, this is an old junk rod I had laying around because we don't use these. We chuck them and change them. But if you look right down the beam right here, you'll see a very, very narrow parting line. That's because that's where the molds came together, and that's how you can tell this is a cast rod, because of the heavy stippling, just like a cast iron block on the outside of an engine block or anything cast iron like that, and the thin parting line. If you have rods like this in your motor and you're going to run nitrous, I wouldn't recommend it. They're not the strongest rods in the world. If you're going to do a small shot, 50 or 60 horsepower or something like that, 75 or under, probably fine. You know, this is a beefy sized rod. This is out of either a Pontiac or an Olds or something like that. So it's a pretty heavy duty rod just because it's size. Of course, if it was a small rod, and it's obviously not going to be as strong. But you should probably stay away from those type of rods. But all the Fords, pretty much all the Fords, almost all the Chevys, all those types of rods, they're all forged. They're all forged steel. So let's look at one right here. This is a typical small block Chevy rod. It's a factory rod, and it's been worked on. This was real common back when I was a kid. We used to do this kind of stuff because aftermarket parts really weren't available so much, and the ones that were very expensive. You know, a good set of rods back then were, oh God, $1,000. Now you can buy a good set of aftermarket rods for, oh, a few $100, and they're good steel alloy. But looking at this rod, let's just see what someone did here. If you look at the beams, this was a common thing to do, is to polish the beams out. That relieves stress risers. Anytime you have a stress riser, imagine trying to tear an envelope full of paper in half. If it's inside an envelope and it's got a rounded corner and you're trying to tear it and it's got, 50 pages inside and they're all folded over, it's hard. But if you fold the paper over and start on the ends, you can tear it easier. because you got all the little edges that can tear up. Well, same thing here. All the edges are removed. So if it's going to crack or try and break, it wants to always start from a stress riser. Stress risers are relieved. It's all polished off. It's been deburred a little bit and kind of polished up a little bit. That's all fine and dandy. People think that really adds a lot of strength. In my book, I don't think it adds anything. I mean, maybe 1%. It's not worth the effort. Rods don't really break on the beam anyway. Really what kills a rod are the rod bolts. Now, someone went through all this trouble to make this rod nice. They polished it and profiled it and everything, and they left the factory bolts in it. They didn't even go to an aftermarket bolt. Anytime you're going to upgrade a motor, you always, number one, always replace the rod bolts with something like an ARP bolt, at least an SPS bolt, but an ARP, a good high-quality ARP alloy bolt. Put it this way, here's a connecting rod. This thing's going up and down with incredible force inside the motor. Every time this thing hits top dead center on top of the piston, it gets yanked back down. All right, well, every time, that's on the exhaust stroke. On the power stroke, it's being pushed back down, so the load is on the beam right here. That's not really where the problem's at. Usually it's on the exhaust stroke. When it comes up and you got the weight of the piston, and in a nanosecond it stops, changes direction, gets pulled back down. Guess what's getting pulled back down by? The cap. So what's holding this cap on? The two bolts, nothing else, the two bolts. If these bolts stretch or start coming loose, that's going to move this cap and distort it. The bearing's going to come loose, and what do you do on a rod? It spins the bearing, and you got the bearing spinning in there. Now it chews up the crank, creates a lot of heat here. What happens eventually is it goes back up, as it creates the heat, it's distorting this cap. It pulls the cap off, all right? So now the rod and the piston sitting at the top, it smacks the head, and it's sitting at the top, and guess what happens? Crankshaft's still turning. You got 7 other cylinders turning that crankshaft around. You know what happens? It smacks the rod and goes, pow, throws it outside the block. And then people go, oh, my rod broke, as it breaks it right across the beam. And they go, oh, my rod broke. Wasn't the rod's fault, it's the rod bolts. Always replace the bolts. That's the only thing holding the rod cap on, and what's holding the bearings in place are the bolts. So make sure you do that. Whoever did this, they just left the stock bolts in. That was kind of a dumb thing to do. You don't want to do that. So we go over here to this next rod, this guy right here. This is an aftermarket rod. This guy is a Eagle rod. It says ES on there, forged right into it, Eagle Specialties. Scat makes some really good rods too. These are very good bang for the buck rods. Very cost effective. They're made out of 5140 alloy steel. Some rods are made out of 4340. It's just alloys of the different toughness and strengths of the steels. But it looks like a stock rod, but it's really not. If we look at it, here's we can tell also it's a forged rod. You can see the parting line right up the beam here is really wide. That's from the forging press coming together, and it leaves a wide parting line. But it is forged, like I say, very few of them are cast. This one, if you look real close to it, doesn't have a stud and a nut on it. This has a through bolt. Those are a little stronger than a stud and a nut on the rod. So these are ARP. They usually say ARP right on the ends. They'll say like Eagle or ARP just right on the end. All ARP bolts say ARP on them. They're always etched into the bolt. These are really strong. The alloy of the bolt's like 190,000 PSI, which is really strong. That holds that cap in. And if you look at the cap, it's nice and thick. It's thicker all the way around. The whole rod is just thicker. And what's interesting is it's actually a little bit lighter. It's a very strong alloy. This thing will take all kinds of abuse, up to about 500 horsepower. These things are dynamite. And they're really inexpensive for what you get. But obviously that cap's going to stay in place better because the bolts are holding it better. If you're going up to high horsepower, 500 and above, 750, 800, 1,000 even, you're going to get into an H-beam rod. And the difference between an H-beam rod and an I-beam rod, they call these types of rods I-beams, because if you cut this rod in half and you look at it, it looks like a capital I. It's a straight line with the top and the bottom on it, almost like I-beam steel that they have in buildings holding the roofs up. This one right here, if you cut it in half, it's like an H, just by the way it's shaped inside. It's a lot stronger, tremendous strength in this. Same thing with the bottom. You got 2 giant ribs going across the cap. Giant bolts. These are 7/16 bolts, where all the other ones are 3/8. So it has giant, heavy-duty bolts holding this cap on. And look how nice and thick that cap is. This isn't going anywhere. The beam is super strong, so it stops deflection and flexing and bending and moving. So it stays intact quite well. So any big horsepower numbers, you're going to want to run like a 4340 H-beam like this. And really, you know, aftermarket companies, Scat, Eagle, any companies like that, they're really not that expensive. Several $100s and you got a set of rods where, like I say, even back when I was a kid doing this stuff, they either didn't have them available or they were 3 times that price. So now prices are actually coming down compared to what they once were. So we're going to look at pistons next. Stock pistons in a stock engine will work with nitrous. We use that word again, moderation. If you keep the power levels of the nitrous within reason of what your engine can handle, you won't have any troubles. Obviously, though, if you're going to increase the power and you're going to say, hey, let's go to the high end of this, or I'm going to buy, a dual stage system, you're going to want some heavy duty components like this in your motor. Same thing with pistons. The only thing taking the load inside the combustion chamber when the heat and everything expands is that piston. It had better be strong. Cast pistons are brittle. I mean, if you could pry apart a cast piston, it would snap. Just like I talked about the connecting rods, a cast iron connecting rod, they're brittle. They want to snap. Forged pistons, the way the molecules are in the alloys of the aluminum, they tend to give a little bit. And if you could actually pull one apart, it'd be like cold peanut butter. It really wouldn't pull apart very well. They don't like to break. It's just the way, it's the only way I can kind of explain how it is, about the way they work. Put it this way, if I took a stock piston and I held it up and I took a ball peen hammer and whacked the top of it really hard, it would crush. I mean, it would actually, they're very, very thin because they're not designed for high horsepower. They're very, very thin, and it would actually crush. So you do a forged piston, it'll dent. I can beat the hell out of this thing and it'll just dent. Okay? This right here is a JE piston. Actually, it's their lower line piston. It's SRP. If you look inside there, it says SRP right inside. This is a really good bang for the buck, high-end piston, fully machined. This one's a dish, so it's for lower compression, like a supercharger or anything like that. Very good quality, very lightweight compared to a stock piston. This is probably about half the weight of a standard stock piston of the same size. And it's about 10 times stronger. It's worth the money if you're going to go in. Going into big nitrous shots or supercharging, anything like that. There are other types of pistons, though. There are hypereutectic pistons. And basically, a lot of people get that confused. They'll say a hypereutectic piston is almost as strong as a forged piston. They're still brittle. You have to be careful with that because it's still a cast piston. The word hypereutectic just means high silicon content. They just have a lot of silicon in there. And what that does, it's just the way the granular structure of the piston is, it adds silicon in there, so it's a little anti-scuffing effect against the cylinders. It actually kind of glides. If you look at the molecules, instead of all aluminum molecules, you got aluminum, silica, aluminum, silica, stuff like that. So it's for every X amount of aluminum molecules, you have a silica on there, and silicon. And what that is, it's just the way it bonds the molecules together. But they're not forged, they're cast, and they're only so strong. If you're going to spend the money for those and you're building a motor specifically for nitrous, you might as well spend a couple of bucks more, get the forged pistons, be way stronger, and be done. So sometimes don't cut corners on stuff like that. You can cut corners someplace else down the road, but the internal engine components, that's the base of the motor. You might as well make those as strong as you can get. Now, you don't have to get crazy on price. You can come up, and this piston right here, this is made by Sealed Power. A lot of you know it as TRW. They changed the name a few years back. They went ahead and called themselves Sealed Power. This is also a forged piston from Sealed Power. It's a little heavy. It's quite a bit heavier than the SRP piston than what JE makes. But bang for the buck, this is a good solid piston, and they're relatively inexpensive. And this will take pretty much all the abuse you can throw at it, within reason, but pretty much all the abuse you can throw at it. And for a couple $100, you can have a set of pistons like this. These are not much more than a set of hypereutectics, a few dollars more. So again, if you're gonna purchase something like cast pistons or upgrade to hypereutectics, you might as well just spend a couple of bucks more and at least get a good set of Sealed Powers like this, and you'll be done. Sealed Power makes pistons for American cars. They're getting into the import cars, so all you import guys out there, they make stuff like this too. So you don't have to get crazy on the price to get a good quality product like this. While we're talking about forged pistons and the strengths and stuff, you got to keep in mind, even a good forged piston can only take so much abuse. And you're at the mercy of expanding metals, because heat, I mean, you're adding more fuel and an oxidizer inside the combustion chamber, you're making more heat. Heat expands metal. Metal has to have a place to go. Well, you have to talk about also things like piston skirt clearances and ring gap distances and clearances. And on a nitrous motor or a supercharged motor, anything like that, anytime you add cylinder pressure or add more fuel and air into the combustion, you're going to increase the heat. Heat expands the metal. It has to have a place to go. So piston skirt clearances on the side need to increase. And sometimes it's as much as double of what factory is, sometimes even more. A factory piston might have 1.5 to 2 thousandths clearance. A nitrous piston might have 5. You know, 3, 3.5, 4, sometimes 5, depending on how big the shot of nitrous is. Obviously, the bigger the shot of nitrous, the more shot of fuel is going to go in there. The higher the heat, the more that's going to expand. And you got a piston that's captured in a cylinder. And the aluminum is expanding at a given rate, and the cast iron cylinder is expanding at a given rate. Aluminum expands more than the cast iron, so it has a place to go. And as it's going up and down the cylinder like this, as the clearances get tighter and tighter and the heat increases more and more, it gets tighter on a cylinder, until finally it welds itself together. That's where the misconception was when people go beyond the moderation. They add, they say, oh, the 50 horse shot worked real good. Let's put the 150 in. Well, the clearances inside the motor couldn't take the kind of heat, and the piston clearances on the skirts, you heated the piston up beyond where it could possibly go. It used up that factory 1.5 thousandths clearance. The piston wanted to expand 4 thousandths. Now you got a 2.5, 3 thousandths interference fit. Yeah, you're going to weld the piston right to the cylinder wall. So that's where you get bad reputations. Same things with ring gaps. The rings are also heat sensitive. You have a gap on the ring. I'll show you right here. All rings have a gap. And when you expand them and put them over the piston, the gap is wide. When you put it in the cylinder, they close up to a given factor. So the ring gap will be at a given factor. Okay, well, as cylinder pressures and heat increases, this ring gets tighter until it butts together. If it butts together in there, things happen, bad things, because now there's no space. So that ring, believe it or not, can break the top of the piston, or the ring lands in the piston. And this is a really common cause of really bad piston problems and bad engine problems, because when this happens, it's catastrophe. I mean, the piston breaks. So you have to, anytime you're building an engine for nitrous, you have to take this kind of stuff into consideration. The more nitrous you put, the more heat. The more heat, you need wider clearances so the metal has a place to go. So ring gaps, like a factory ring gap, might be 16 thousandths, 17 thousandths. On a regular performance motor without nitrous, it might be in the 19 to 20 thousandths. When you get into ring gaps for nitrous oxide, oh shoot, you can be in the 26, 28 thousandths pretty fast, sometimes 30, 32 thousandths. That's that's twice what the factory was. So you're going to double sometimes the piston skirt clearance, and you're going to double the ring gaps. Guess what else happens? Well, you're going to smoke a little bit. Nitrous motors and motors set up for superchargers for all this type of high cylinder pressures and high heats use a little bit more oil, and they tend to smoke a little bit when you're not on the nitrous, because obviously the motor's built for all this shot of nitrous and all this shot of fuel coming in. So the motor's built so everything can expand and have a place to go. Well, when you're not on a nitrous, they're contracted and the gaps are bigger, so guess what? Oil gets by there, and you get a little blow-by. If you pull a valve cover breather off and you put your hand over it, you'll feel a little bit of blow-by. That's normal. You might get on the freeway without the nitrous on, lay into the throttle, and you might see a little haze come out the back of some black smoke. Well, sure, a little blue or something like that. That's okay. You might use a quart of oil every here and there. That's fine. It's normal. So you don't have to worry about that. But what you do have to worry about is problems like this. This is a piston right here where the ring gaps were not adjusted right. It's a good forged piston. This is a TRW piston. It's a good forged. They didn't set the ring gaps up. The guy thought he had a good motor. He went ahead and put nitrous oxide to it. It did the same thing a lot of people do. Wow, 100 horse worked good. Let's try 150. Worked real good. Went to 200. Guess what happened? Rings had no place to go. They weren't gapped enough to withstand the heat of 200 horsepower. So they expanded, and guess what it did? It broke the whole side of the piston out. This is what happens. You lose all that right there. Usually they'll break on the top right here. This one broke down on the second ring land. Usually the whole top of here will break off. And guess where that little piece goes? It goes up on top, and it goes up between the piston and the head. And on those, you only have between a 40 and maybe 60 thousandths clearance between the top of the piston and the head. Well, you got a hunk of aluminum sitting there floating around in there like this. Guess what happens? It beats the living crap out of your head, beats the crap out of the piston, stuff gets down beside you, wipe out your cylinder wall. Basically, motor's toast. All because the ring gap wasn't set up a little bit wider, and they would have prevented this problem right here. So it's definitely imperative that you set the motor up for large amounts of nitrous like that, or stuff like this is going to happen. All right, before we end this segment, move on to heads and head bolts and gaskets and things like that, I wanted to add a couple little more tidbits on pistons and compression and things like that. You know, the beauty of nitrous oxide is you can run it with any type of compression. I mean, it can be a 7 or 8 to 1 compression motor, or it can be a 12, 13, 14 to 1 compression motor. Unlike supercharged or turbocharged engine where you only can run low compression, otherwise you'll have detonation problems. And just so you know, low compression pistons, they're dished like this. They usually have a dish in them. Or when you get into high compression pistons, they'll have a dome. It'll be just the opposite. You have a little dome that sticks up. And that's kind of one way to tell if you got a high compression or a low compression piston. Of course, this has nothing to do with what compression it is or how much compression you really have, because the combustion chamber size also has a lot to do with it. But I just wanted to talk about that and the different types of compressions. When we talk about different types of compressions, there's static compression and effective compression. So let me kind of give you an idea. Say your motor has 9 to 1 static compression. That means as it's sitting there naturally aspirated, that's the kind of compression it has, 9 to 1. Anytime you add nitrous though, obviously you're adding fuel and an oxidizer in there, and it's going to increase the burn and the burn rate. You're going to increase the speed of the burn and the pressure inside. That's going to increase your compression. So that's what we talked about earlier in a fuel segment about needing more octane, because your effective compression is going to go up. So your static compression might be at 9. That's your static compression is what you figure out on paper. You say, well, my swept volume, my combustion chamber size, and the piston dome and compression height size, and all that kind of mumbo jumbo you need to figure out to make to get a correct compression ratio. That has nothing to do with how much fuel is going to go in and how much pressure it's going to make. Obviously, when you hit the nitrous button and you dump a bunch more fuel in there in an oxidizer, you're making a bigger bang that increases the pressure. Well, compression is all about how much pressure is in there. That's the effective compression ratio. So your effective compression is going to go way up. And that's how pistons break and you have detonation problems, and why you need higher octane, things like that, because you can have an effective compression increase of about, 2, 3, 4 points. So meaning you could go from a 9-to-1 motor, you might go up to a 12 or 13-to-1 compression on effective compression because of the nitrous being in the motor. Well, what kind of octane would you need to run if you had 13-to-1 compression? 108, 114? That's why when you're on the nitrous, you need to add extra octane in there, because your effective compression just shot through the roof. So you're not still at 9-to-1 compression anymore. But that's kind of that on pistons. One thing you have to remember too on the load on pistons with nitrous oxide is anytime you hit the nitrous, you're increasing horsepower. You ever hear a high horsepower engine rev up? Boy, they're fast. They tack up fast. You know, they're runga, runga, they're real fast. Okay, well, anytime you increase the speed of the RPM of the motor, how fast it can tack up, you're increasing the kinetic energy loads on components inside the motor, meaning like pistons and connecting rods. So let's look at this. And we talked about this earlier about the piston hitting top dead center and getting yanked back down. All right, well on the exhaust stroke, there's no load other on the piston being forced down. It's just a connecting rod pulling. Well, when an engine tacks up real fast, that's why it's real bad to free wind an engine, just sitting there in a parking lot neutral and just revving a thing up. It's not real good on the motor. It's not under a load. Well, bad things can happen. Well, what can happen on a nitrous motor is things like that is when you're on the juice, the RPM flashes up so fast, kinetic energy increases, you can rip a wrist pin out of the bottom of a piston. That's another reason you're going to want a forged piston. And again, here's back to this one forged piston. This is the trouble we had. The guy also ripped the wrist pin out of this thing. And this is typical. Even a good forged piston, you can break that out. So you got to watch that and keep that in mind, that it's not just the loads. I mean, there's so many factors involved. Nitrous is so simple, but there's so many factors involved that can dictate what can happen inside the motor for things like this braking and stuff like that. So you want to, again, we're back to that word moderation. Keep everything in moderation, and crap like this won't happen. You'll have a good, strong, running engine that'll last you a long time. Start pushing that limit, and stuff like this is going to start happening. All right, we're going to talk real quickly here about cam profiles for nitrous oxide. Basically, pretty much any type of cam can be used, but one thing that you keep in mind with nitrous oxide cams is there's a measurement called the lobe separation angle, LSA. Some people call it lobe separations. Nitrous oxide profile cams have a wider lobe separation. They're usually in a 112, 113, 114 degree area, where to give you an idea, a regular performance cam for like a race motor might have a 104 or a 106 or a 108 center line, and that's just the amount of degrees between the lobes. So a wider center line, say 112, would be, the lobes would be separated X amount. 106, they'd be in a little bit closer. That just has to do with the overlap of the cam. Again, pretty much any type of cam profile can be used, but to utilize the pressures of the cylinders a little bit better, nitrous profile cams are very similar to like supercharger cams and turbocharger cams. So best thing to do is call the cam manufacturer. If you're interested in a comp cam or a Crane or a Crower, call Comp, Crane, or Crower Tech Lines, and they'll be glad to help you set up a proper cam spec and a proper cam for your particular engine and driving needs. We also have a DVD on that. It's called Heads, Porting, and Valve Trains. It's about 5 hours just covering heads, porting, and valve trains, and we go into that in a great extent. If you really want to learn about that stuff, because it is a mysterious subject that a lot of people don't understand, and we go into it in pretty good detail. So be sure to pick that up if you really want to learn about this. But nitrous cams, like I say, a little bit wider in the lobe separation, and pretty much lift doesn't have a lot to do with it. Advertised duration doesn't have a lot to do with it, and duration at 50 thousandths really doesn't have a lot to do with it. It's kind of like lower cams, same thing. The lift and duration doesn't have a whole lot to do with it. It's the overlap and the lobe separation angles that do. And again, any cam manufacturer, the tech line, would be glad to help you. Same thing with a nitrous tech line. You could call Nitrous Supply or NOS or any of those companies, and they'll be glad to help you pick out a good cam profile too, because it's important to get a cam profile that'll help your vehicle do what it's going to do, because the cam dictates how it's going to run, where it's going to make its power at, and how much cylinder pressure you're going to be able to use. Your effective compression, we just talked about that, and also static compression. Your static compression is a given, but the effective compression, depending on the overlap and the scavenging effect that you get in the valves and the combustion chambers, that all has variables, and a camshaft can also help do that. So meaning basically a poor cam profile, something with a very narrow lobe separation angle, you're not going to get the potential out of your nitrous system as if you had a camshaft that had a better profile that's more nitrous friendly. So check that out, call the cam manufacturer, the nitrous supply, and they'll be glad to help you with something. All right, now we're going to talk about heads. You know, there's a lot of misconceptions out there about aluminum heads. You know, they blow head gaskets, they're not very stable, they warp, they crack, and that's really a bunch of BS. Actually, aluminum is the best thing you could run, especially with nitrous or a supercharger. Anytime you're adding high cylinder pressures and high cylinder heat, aluminum is the way to go. Aluminum throws heat. A lot of people say aluminum is just lighter. It's not just about being lighter. Aluminum dissipates heat extremely fast. So every time the piston comes up and fires in that combustion chamber to make all that heat, as it comes back up and forces it back out the exhaust valve, it strokes back down inside and sucks new fuel and air inside. Well, that incoming fuel and air charge is cold, and it cools that combustion chamber down. Aluminum cools down much, much faster than cast iron. Just to give you an idea, if I heated this head up here to about 200 degrees, came back about 15 minutes later, I could touch it. If I heated this cast iron head up to 200 degrees, came back about 10 minutes later, I'm going to burn my fingers on it because it hasn't cooled down. That's why Grandma used to like to cook with her old cast iron skillets. They just cooked very well. They held the heat in. Aluminum doesn't. So that's one of the advantages. Another advantage is, the reason we want it cool, less detonation problems. This is why aluminum heads with nitrous is almost a must. I wouldn't build a nitrous engine in my shop here with cast iron heads unless it was absolutely necessary, like say it was a early Shelby or something like that, and it had a factory hypo motor in it, a factory Shelby motor in it, and we wanted to do a hidden system. Well, we'd have to use a cast iron heads. We had a hidden nitrous system in there, but you want it to appear stock on the outside. You're kind of stuck doing that then. But if you're building any type of performance head or performance engine at all, you're going to want to use aluminum heads. Another thing about aluminum, they're repairable. It doesn't really warp or crack like, you know, have been said in the old days. Let me kind of tell you where that came from. When aluminum heads first came out, two of the big engine manufacturers, two of the big actually car manufacturers out there, decided to put aluminum heads on for mass-produced vehicles. The problem was they machined the head surface here the same surface that they did the blocks on. And if you look at an engine block, especially an early vintage block, you'll see ripples on the deck surfaces. That's so the head gasket grips. When you clamp the head down, it actually grips the gasket. Problem is, aluminum expands about 2 times or a little more than 2 times that of cast iron. So if the cast iron block expands 2 thousandths, the head's expanding 5 or 6. And it's not uncommon for an aluminum head to expand 5 or 6 thousandths. That's pretty normal. That's about what they actually expand. So what happens was, if you look at this head right here, it's a nice smooth surface. It's very, very smooth. It feels like a mirror. It might not look like it because the tooling that went across it, but it's actually as smooth as like a mirror, a piece of glass. What happened was, when they first came out with aluminum heads, this surface wasn't like that. It was like what you do on a cast iron block, and it has little ridges in it. Well, those little ridges acted like a draw file across the head gasket surface. So as the engine expanded like this, the heads are expanding this much. So with those little ridges on there, they're skating across the head gasket back and forth, and eventually it tore through the gaskets and would wipe the heads out, or wipe the gaskets out. So in 20, 30, 40,000 miles, you needed new head gaskets. Well, almost every modern car now has aluminum heads. In fact, a lot of them, the whole motor's aluminum. And they're not having troubles. You know, you don't see any new Vets or anything like that having troubles. Vipers, I mean, a lot of cars like that have aluminum heads. They're not having any troubles. My new diesel truck has aluminum heads on it. No troubles either. Once we figured out in the machining industry that if we smooth this surface out and allow it to smoothly skate across the head gasket surface, no more head gasket problems. So it really wasn't the aluminum head's fault. It was actually the manufacturer's fault for not doing the machining correctly. Another cool thing about aluminum, it's repairable. If you have a problem where you did have a little melting down inside or anything like that, or a valve came off, or you had some sort of catastrophe problem, you can TIG weld aluminum like that, machine it back down, it's as good as new. Cast iron, not really repairable. You can do some cast iron welding, but it's not the greatest. It's definitely not 100% fix. With aluminum, this is A356 aluminum. Almost all heads are made out of A356 aluminum. You can use A356 rod and TIG weld it in, and it's basically as good as new. And you machine it down, you can barely even see where it was. Cast iron, it doesn't really do that. It's a big, long process to weld a cast iron head. It's expensive. You can't just braze it. Some people will braze it, and it's like, don't do that. That's just not good. But a real cast iron weld can be a $300 or $400 weld, because I got to heat the head up to some tremendous amount of heat. They get it glowing cherry red. They pull it out of the oven, they weld it, then they throw it back in the oven, they heat it back up again where it's cherry red, then they slowly cool it down over 24 hours or over a long period of time like that. And it's costly. Like I say, a single weld on a cast iron head can be $300 or $400. There's nothing to weld one of these things. So there are advantages to heads like this. And we're going to talk about head gaskets also. If you look at a Chevrolet head, we're going to compare a Ford to a Chevy, the old good Ford versus Chevy fight going on here. And really, you're talking apples and apples. They're both the same. For every give, I've said this earlier, for every give, there's a take. Okay, there might be something a little bad about this one, but this one's got something bad somewhere else. Okay, or this one's got something good, and this one's got something good in another area. They're all the same. You know, even Ford heads, aluminum heads, aftermarket heads, they run the same valve. If you look up the valve part numbers for a Ford or a Chevy, same number, same valve springs, same seals, same retainers and locks and studs and guide plates. A lot of them are all the same. It's just the head design that's a little different. But these days, it's pretty all the same. But on gaskets, just because of the design of the engines, there are some differences, and we're going to talk about that. Chevys really don't have a head gasket problem. You very rarely hear about a Chevy blowing a head gasket. Why? There's 17 head bolts holding this head down onto the block. Fords, there's 10. Whether it's a small block Ford or a big block Ford, almost all Fords have 10 head bolts. If you look along the head, right here, you got each combustion chamber. Of course, this is just an old junk head I got laying around. But if you look here, these are the head bolt holes right along here. And of course, if you look, there's 2, 4, 6, 8, 10. There's nothing in between here. Fords are prone to blowing head gaskets in nitrous oxide motors and supercharged applications. They have a little problem. Well, there's a remedy for that. There's a head gasket that Felpro makes. It's called a 1006 head gasket. This is it right here. What this is, it's a basic composition head gasket, but the fire rings right here are steel. And the fire ring is actually thicker than the gasket. There's a stainless steel wire inside here that doesn't compress. Anytime you put a head gasket on a head and you torque the head down, you're compressing the gasket. You're actually flattening it down. Okay? Well, what happens is this gasket flattens except this little area around this fire ring right here. Okay? And what happens is you take the Ford head and you machine it. And we do a machining process for cutting it for the, this is what they call an O-ring head gasket. We cut it for the O-rings. And if you look right in here, there is an O-ring groove all the way around. It's what they call a receiver groove. We've machined that in this head. Well, that way, when we put the head gasket on, and fit like this fire ring fits up in that receiver groove, and it basically creates an O-ring seal. Now this head gasket is almost impossible to blow. Well, nothing's impossible, but close to impossible to blow. It's a lot stronger than it was without that O-ring, without the O-ring groove. What you can't do is take one of these gaskets and put it on a head that does not have these grooves cut in it, or you will have a head gasket leak problem because they're not designed to crush the fire ring area right here. That stays uncrushed and goes up into this receiver groove here. So you can't use these unless you send these out to a machine shop and have them cut. It's not very expensive to have done, and it's cheap life insurance, especially for a nitrous oxide motor. You definitely want to do that. Chevys don't have that because they have 17 head bolts. We'll go into that next when we show you the blocks. All right, so here we are with a typical small block Chevy, and here's a big block Ford. Even though it's a big block and this one's a small block, the head bolt configuration is still pretty much the same. So we'll look at this one right here. On the small block Chevy, we just talked about this, they have 17 head bolts. So we look at a typical cylinder right here, and you look, and there's 1, 2, 3, 4, 5, almost all the way around on head bolts that clamp that head gasket against the deck surface here. It's that way all the way across the whole surface area, or all the cylinders right here. They all are totally circumferenced around and holding that head gasket down. Fords don't have that. You come over here and look, here's your typical Ford. They have 1, 2, 3, 4. 4 bolts because they have 10 across where the Chevy has 17. Well, you look in this area right here and it's wide open. There's nothing clamping the gasket in this area or in this area, in this area, or between the cylinders. So you've got a lot of areas right there that are apt to blow a gasket, where the Chevy has bolts in here. And this is this way all the way across the same thing, all across all the cylinders like that, same thing. So no matter where it is on the Ford, there's less bolts clamping the head down against the head gasket and keeping it in place. So we have to consider this. One thing, first and foremost, I said this on the connecting rods, always use the best bolts you can buy, like ARPs. I mean, you can't go wrong with that. Let me talk about bolts for a minute. First, think of this. The only thing holding your motor together are the bolts, period. Whether it's holding the connecting rod cap on, it's holding the head down against the deck surface, holding the main caps in place, anything like that, the bolts. Now, a lot of you look at bolts and they say, oh, well, I reused the factory bolt. They looked fine. You can't tell if a bolt's good by looking at it. That thing's been on there since, this is probably about a 1960-something block or early 70s block. This thing's, almost 40 years old, 35 years old. That bolt's been clamped on there for how many years, and it's been heated and cooled and heated and cooled under torque. I mean, it's been torqued, it's been stretched and sitting there. Every time you heat it and cool it and oil quench it, because you got oil inside the motor, you're hardening it and then softening it and then hardening it. It's gone through hell and back, okay? So you might look at it and go, well, the threads look good and everything. Yeah, but when you torque a bolt down, it stretches and it acts like a spring, and that's what clamps it down, whether it's the head against the deck surface or the rod cap on or the main cap in place. That's what holds them. That's why they don't use lock washers. You actually stretch it. It's supposed to stretch. You get to a point, though, where they've stretched so much, they're not elastic anymore. You tighten it down and they don't hold their clamping force. So looking at it visually, you don't have x-ray vision. You can't tell. Okay? The only way you can tell if a bolt's good is to put it in what they call a Rockwell tester. Guess what the Rockwell tester does? It puts it in the machine and it pulls on it, pulls on it, pulls on it until it goes pow and breaks. And then you go, oh, that one was strong. Yeah, but you can't reuse it. The doggone thing broke. The only way you can test them in a Rockwell tester is to break it to find out how strong it was. Well, that doesn't do you any good. What does do you good is to buy a good set of ARP bolts. These are $190,000 up in that range to sometimes $220,000 for the Pro Series bolts. They come with parallel ground washers, super strong. Even these, though, you can only use them so many times because any bolt can only take so much. But always start with the best you can buy. ARP, you're not going to go wrong. And shoot, they're only like 30 or 40 bucks for a set. Well, that's cheap. Trust me, when you blow a head gasket out and you're sitting there repairing it, you're going to go, man, I'd pay 3 times the price of a set of bolts right now to not have to screw with this crap right now, because everything gets dirty, you got to tear it apart, you're not out driving your car, all because you went cheap and saved the factory bolts. Not a smart move. Don't cut corners in areas like that when you're building performance motors, or it's going to come back and bite you in the ass. You don't want to do that. So be sure you start off with really good components first, especially in areas of head gaskets. You're putting nitrous oxide in there, you're increasing the temperature and you're increasing the cylinder pressure 2, 3, 4, 5-fold. Okay, so obviously you're going to want to clamp these things down as good as you can. I know I'm kind of going into this a little bit, but I can't stress it enough. I did it on the connecting rods also. Use good bolts. It's the only thing holding the motor together, so start off as good as you can. All right, so I think we've seen now that nitrous oxide by far is the biggest bang for the buck, dollar for dollar, compared to any other power adder. You think about it. You can add a cam, you can add heads, headers, intake manifold, exhaust system. I mean, you can spend thousands of dollars on all kinds of other goodies that might increase your horsepower maybe 35 to 50, maybe even 60 horsepower. Nothing compares to nitrous oxide. Take a supercharger, $3,500 to $4,000 for an underhood centrifugal supercharger. Yeah, that's real good, but that's several $1,000s. How about a few $100 for a nitrous system and a couple hours for installation, and bam, you're down the road. Keep it in moderation and you'll have that motor running for a long time and years of fun. Keep in mind we have other videos with all kinds of other subjects you might want to check out: heads, porting, and valve trains, and superchargers, engine building, performance tuning. We got all kinds of stuff. Have fun with it, and remember, knowledge is horsepower.